Hi, this is Josh from Over the Shoulder Coding. Today I'm walking day 8 of the Advent Code 2018 challenge. Memory maneuver. The sleigh is much easier to pull than you'd expect for something its weight. Unfortunately, neither you nor the elves know which way the North Pole is from here. You check your wrist device for anything that might help. It seems to have some kind of navigation system. Activating the navigation system produces more bad news. Failed to start navigation system. Could not read software license file. The navigation system's license file consists of a list of numbers, your puzzle input. The numbers define a data structure which, when processed, produces some kind of tree that can be used to calculate the license number. The tree is made up of nodes. A single outermost node forms the tree's root, and it contains all other nodes in the tree, or contains nodes that contains nodes, and so on. Specifically, a node consists of a header, which is always exactly two numbers, the quantity of child nodes and the quantity of metadata entries. Zero or more child nodes as specified in the header, metadata entries as specified in the header. Each child node is its that has its own header, child nodes, and metadata. For example, we have some input, and the first two numbers are 2 and 3. So 2 for node A has two children, B and C, and three metadata entries, 1, 1, and 2. B has zero child nodes and three metadata entries, 10, 11, and 12. C has one child node and one metadata entry, which is 2. And D has zero child nodes and one metadata entry, which is 99. So they've explained it down here as well and wrote out the tree structure so you can see. So A is the topmost node, and then B and C are children of A, and D is a child node of C. So the first check done on the license file is to simply add up all of the metadata entries. In this example, that sum is 1 plus 1 plus 2 plus 10 plus 11 plus 12 plus 2 plus 99 equals 138. What is the sum of all metadata entries? So we could get our puzzle input, which is huge, or we could start with a subset of the problem, which usually helps in problems like this. So there's some sort of recursion or dynamic problem going on. So we're going to break it down into the smallest problem possible, which is 0, 1, 9, this node here, D, which has 0 children, 1 metadata entry of value 99. So we're going to make that our input. So we can get our input values, which are the numbers split. And then we have to make a way of constructing a node. So So node has children and metadata, so we're going to store that in our class for node. And when we initialize it, we're going to get the first value from the input stream and set that as the number of children. So input values dot maybe pop, or that's getting the last character. So let's look at the values in this root. So what we did is we are getting this number of children by popping the first value in the input stream, getting the number of metadata entries. And for each children, we're going to recursively try to create a child and append it to its list of children. And then we're also going to get the metadata by popping each value. So let's see what we get when we have the root. It has no children like we expect, and it has one metadata, which is 99. So that looks good so far. Let's see if we use our whole input, what we would get. All right, so our root has metadata 112 just like A. It has 2 children, 3 metadata. And the first one has 10, 11, 12, just like B does here. And so the next one has C, and its metadata is just 2, which is correct. And we have 1 child, which is D. All right. So able to create a node, but what we need now is to sum the metadata in a node. So let's see. That's correct. Let's try it with the total input. 4,036. So let's see if that's right. All right, that's the right answer. So you got 1 gold star, and let's continue to part 2. So how do we do that? Just really quickly, we recursively created all the nodes, and each time we were going through a node, we were popping off each of this next letter. So we would pop off this to get the number of children, pop off this to get the number of metadata, and then we'd recursively go and solve the children and do the same thing there. And then when we'd be done with the children, then we would pop and get the metadata, which is what was going on. So first we do the children, then we do the metadata. And then when we sum the metadata, we sum each node's metadata, then we sum the child's metadata for all children, which will recursively check all the children and return that sum. So in part 2, the second check is slightly more complicated. You need to find the value of the root node A in the example above. The value of a node depends on whether it has child nodes. If a node has no child nodes, its value is the sum of its metadata entries. So the value of node B is 10 plus 11 plus 12 equals 33. So B is here, it has no children. And the value of node D is 99. However, if a node does have child nodes, the metadata entries become indexes which refer to those child nodes. A metadata entry of 1 refers to the first child node, 2 to the second, 3 to the third, and so on. The value of this node is the sum of all values of the child nodes referenced by the metadata entries. If a referenced child node does not exist, that reference is skipped. A child node can be referenced multiple times and counts each time it is referenced. A metadata entry of 0 does not refer to any child node. For example, node C has 1 metadata entry, 2, right there. Because node C has only 1 child node, 2 references a child node which does not exist, and so the value of node C is 0. Node A has 3 metadata entries, 1, 1, and 2. The 1 reference node, A's first child node, B, and the 2 references a second child node. Because node B has a value of 33 and node C has a value of 0, the value of node A is 33 plus 33 plus 0 equals 66. So let's use our original input again. Let's call get value. So if there are no child, then its value is the sum of its metadata entries. So if self dot num children equals 0, return get metadata sum. So this is going to be sum of just that node's metadata because it has no children. Else, we're going to go to the metadata and get the value for each child in that metadata position. For metadata in self.metadata for child in child equals self.children dot get metadata default to none. If child not none, then we will get the child's value. Otherwise, we're going to add 0. We can kind of ignore that. And try it out. So let's try it out with B first. That's our smallest test case. We get 99, and we can try it with B, which was 0, 12 expected. So let's try it out with C. And we should not be able to access this second child because C doesn't have 2 children. So we need to check for index out of range first. If metadata greater than equal to or greater than self.children, number children, greater than, we will return 0 and exit. So we could also say if metadata is less than some so if the metadata is saying 1, so here's 1, they were getting the first child B. So we need to add metadata plus 1. And if metadata is equal exactly, we would be getting the last one. So we're going to do equal. Actually, we're going to do metadata minus 1. So if metadata is 1, we're getting the 0th entry. Let's try that. So C returns 0 as expected. Now let's try it for the full set. Okay. We get 66, just like we expected. So let's do it for our full input. And see what we get. 21,677. All right, that's the right answer. So we got our second gold star for the day. Thanks for watching this video. If you liked it, please hit that thumbs up button. If you're still confused about get value, what we did is for each number, if there's no children, then we're simply doing the metadata sum on itself. So we're summing all the metadata values in this array we created here. Otherwise, if it does have children, we're going to use the metadata as indices onto the children. So if the metadata points to a child, so if the metadata is less than the length of child, we'll get that child that it points to. And if the child exists, we will add the child's value to our running total of the sum and return it. So we'll recursively sum all the children that we're going through. So for the root, we will get the value for all the children and sum that up. So that's how we solved part 2. If you like this video, please support me on Patreon so I can continue making more, and subscribe so that you'll know when the next one comes out. Thanks, and I'll see you later.